Have you ever just stood there looking up at a big, glassy building and wondered, how does all of that stay up? I mean, it looks so sleek, so seamless. Well, today, we're going to pull back the curtain, or maybe the storefront, and get into exactly how these amazing facades actually work. So let's get right into it. You see a grid of glass and aluminum, and you think, it's all the same, right? Wrong. In the world of architecture, storefront and curtain wall are two totally different animals. They have different rules, different price tags, and you use them in completely different ways. And honestly, getting this wrong on a project is a really, really big deal. So let's make sure we get it right. Here's what we're going to cover. First, the basics. Then we'll dive into the three huge differences: how they're built, how they handle water, and when and where you use them. And hey, for all of you out there studying for your architecture exams, you're going to want to stick around for that last section. Seriously, it's just for you. Okay, first things first. Before we can talk about what makes them different, we have to understand the one huge thing they have in common. Both of these systems are what we call non-load-bearing facades. Now, I know that sounds a little technical, but trust me, this one concept is the key to understanding everything else. So, what does that actually mean? Well, it means neither of these glass walls is holding the building up. Not at all. Think of the building's steel or concrete frame as the skeleton. That's what's doing all the heavy lifting. The glass wall is just the skin. It's a high-tech envelope that keeps the rain and wind out and lets the sunshine in. That's it. So here's the simplest way to start thinking about the difference. Storefront systems, they're for your low-rise stuff, usually just the ground floor. Think retail shops, restaurants, office lobbies. But curtain walls, those are the heavy hitters. They're designed for the big stuff, mid-rise and high-rise buildings, creating those beautiful, seamless glass facades that can stretch up dozens of stories. And now we're going to get into why. Okay, pay attention because this next part is everything. I mean it. If you only remember one thing from this entire explainer, make it this. The single biggest, most fundamental difference between a storefront and a curtain wall is how it physically connects to the building. And these diagrams show it all. Just look on the left. You see how that storefront system sits inside the opening? It's resting right on top of the floor slab. Now look to the right. The curtain wall is a whole different story. It hangs outside the building structure, attached to the very edge of the floor with those special metal brackets. It is, quite literally, a curtain of glass hanging on the building. And that one difference, sitting versus hanging, changes everything. You see, big buildings actually move. They sway in the wind. A curtain wall, because it's hanging, is designed to handle all that movement, what we call inter-story drift across many, many floors. But a storefront? It's just sitting snugly in its little opening. It just can't handle that kind of movement. And that's exactly why you really only see them used for shorter heights, usually about 10 to 14 feet max. All right, on to major difference number 2, water. Rain, snow, condensation. Water is the #1 enemy of pretty much every building on the planet. So how a facade gets rid of it is absolutely critical. A storefront system is pretty straightforward. Let's follow a drop of water, right? It gets in, travels along a horizontal piece, hits a vertical one, and gravity takes over. It all flows down, 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 until it collects in this one channel at the very bottom called a subsill. Then it drains out through tiny weep holes. It works great for a single story. But can you imagine trying to manage the rainwater from a 40-story skyscraper in one little gutter? No way. It would be a disaster. And that's why a curtain wall is so much smarter about it. It uses this really sophisticated system where each and every piece of glass is basically its own self-contained drainage unit. See those zone dams? They trap any water that gets in and immediately kick it back outside through weep holes on the horizontal frame right below it. Water never travels down the face of the building inside the wall. It gets out right away. It's this brilliant localized drainage that lets it handle the intense wind-driven rain you get way up on a skyscraper. Okay, so we've got the how. Now let's talk about the practical stuff. The where, the why, and maybe most importantly, the how much. The applications really just make sense once you know how they work. Storefront is your go-to for the ground floor. Think about the Apple Store, a car dealership, the entrance to a shopping mall. Any place you need big, beautiful glass at street level. And curtain wall? Well, that's for pretty much everything that goes up from there. Office towers, hotels, hospitals. Anytime you need that continuous, high-performance glass skin that spans multiple floors. And here we go. The question everyone wants to know. What's the cost? Well, the difference is huge. A storefront system is dramatically cheaper. We're talking 50 to 60% less, sometimes even more, than a curtain wall. And it makes sense, right? It's less material, the engineering is simpler, and it's way faster to install. With a curtain wall, you are paying for a whole other level of performance. This table kind of sums it all up nicely. You can see right away curtain wall wins on height, energy performance, and water resistance. And a lot of that comes from having a much beefier, deeper frame. Storefronts are more limited for sure, but don't count them out. Modern ones are really efficient, especially if they have what's called a thermal break. That's just a fancy term for a little plastic insulator inside the metal frame that stops the cold from getting in or the heat from getting out. At the end of the day, you pick the right tool for the job. Okay, all my future architects out there studying for the AREs, listen up. This section right here is your secret weapon. I can pretty much guarantee you're going to get a drawing on the PPD or PDD exam that asks you to identify the system. Here's how you're going to nail it every single time. I want you to burn this acronym into your brain. ADSFP. Anchorage, drainage, spandrel, fire safing, and profile. When you see a section drawing, just run through this checklist in your head. It'll give you the answer in like 10 seconds. But let's focus on the two biggest clues, the ones that are almost always there. A is for anchorage. This is the #1 dead giveaway. Find where the glass system meets the concrete floor. Do you see a bracket holding it on the outside face of that slab? If the answer is yes, then it's hanging. That's a curtain wall. If the frame is just sitting right on top of the slab, that's a storefront. It really is that simple. And F is for fire safing. This is your other nearly foolproof tell. Because a curtain wall flies past the floors, it leaves a little gap, and that gap is a chimney for fire. So you have to plug it with something, usually this mineral wool insulation. If you see that detail in the drawing, that perimeter fire safing, you can be about 99.9% sure you are looking at a curtain wall. So when that question comes up, here's how you answer. You be direct, and you use the evidence. The slab edge bracket and perimeter fire saving indicate this is a curtain wall section. Boom. Done. You're not just showing you know the right answer, you're showing you know why it's the right answer. So there you have it. You're in on the secret now. The next time you're walking down the street, you won't just see a glass building anymore. You'll see a story of structure, of water, of performance. And you'll be able to look at it and ask the one question that tells you everything. Is it sitting or is it hanging?